Hello, everybody. Hopefully, you guys are all having an amazing day, and hopefully, I can make it just a little bit better by helping you understand the concept of balancing chemical reactions. Now, balancing chemical equations and reactions might look confusing at first, but once you understand the pattern, it becomes one of the easiest parts of general chemistry. So today, I'm going to show you how to balance chemical reactions step by step using a method that works almost every single time. But before we start, we need to understand what balancing actually means. So in chemistry, we have atoms. Now, atoms cannot be destroyed. But they also can't be created. Now, this is what is known as the law of conservation of mass. So basically what that means is the law of conservation of mass states that if we start with something, we have to end off with that something. So I'm just going to use a very quick and easy example for all of you to understand. So let's say if we start with 2 hydrogen atoms and 1 oxygen atom. I know that looks like a 10, but 2 hydrogen atoms, 1 oxygen atom. That means we need to end with the exact same number of hydrogen and oxygen atoms. So if we started with 2 and we started with 1, we have to finish with 2 hydrogens and 1 oxygen. What we started with is what we have to finish with. So basically what that means is when we have to start with something, you have to get that thing back. That thing can't just magically disappear. Okay? So balancing a chemical equation means making sure the number of atoms of each element is equal on both sides of the reaction. Okay, so here's the biggest rule, is we can change the coefficients, but we cannot change the subscripts. Now, a subscript, for you guys who don't remember, is we're going to use water as an example. Simple H2O. Now, the coefficient is going to be this number placed in front of it. So let's say if we had 2 molecules of H2O, that is the coefficient. We can change the coefficient, okay? But we cannot change the subscript. Now, the subscript in this case is the little 2 beside the H. So, just kind of refresh your memory. This will be a coefficient. This is a subscript. Okay? So, for example, we're just doing this right now. In water, the little 2, oh geez. The little 2 will tell us there are 2 hydrogen atoms. So we cannot change H2O into I don't know, let's see. We can't change it into H2O2 because that would make a completely different substance. But what we can do is we can put a bigger number in front of the water, and we just did that right here. So that means now we have 2 water molecules. So 2H2O contains 4 hydrogen atoms and 2 oxygen atoms. Making sense so far? Okay, let's do a very quick example. All right. So we have an equation right in front of us, and we're going to balance it, okay? So this reaction forms water from hydrogen gas and oxygen gas. Now, we should start with by counting the atoms on each side. Now, what I really like to do is I like to break it down from the product side and the reactant side, okay? So what I'm going to do is I'm going to write the H and the O on both sides, and I'm going to count them each. So let's see. We have 2 hydrogen atoms, and we have 2 oxygen atoms. And on the product side, we have 2 hydrogen atoms and 1 oxygen atom. So the equation isn't balanced. Hydrogen is balanced, but oxygen is not. We have 2 oxygen atoms on the left, but only 1 on the right. So we need to put a coefficient of 2 in front of H2O. Now what that's going to do is it's going to change the amount of oxygen and hydrogens we have on the product side. We now have 4 hydrogens and 2 oxygens. Now the product side has 2 oxygen atoms, which is good. But now we also have 4 hydrogen atoms on the product side because the 2 water molecules means we have 4 hydrogens in total. So we need 4 hydrogen atoms on the reactant side. So to fix that, we need to put a coefficient of 2 in front of the H2. And what does that do? It's going to change the amount of hydrogens we have. So there. Both sides are balanced nice and properly. 4 hydrogens, 2 oxygens. Everything matches. So what that means is the equation is now balanced. Now we're really going to quickly go through a step-by-step method. And here's the method I really recommend, okay? So for step 1 is we have to write the unbalanced equation. Now I'm going to do the formation of water again, just so it kind of makes a lot more sense, okay? So step 1 is write the unbalanced equation. Okay. Step 2 is going to be count the atoms of each element on both sides. And basically what that means is that it's the line separating the products from the reactants, and you do your count. Okay, so we're just going to put that down real quick. So we have H, we have O, then H and O. Okay? Step 3 is going to be balance one element at a time. That is very important because you're going to start jumbling yourself if you're balancing multiple elements at one single time. Okay, step 4 is going to be leave hydrogen and oxygen until the end if possible. So what I mean by that is that we're going to go through a couple examples, and that step is very important for certain kinds of reactions, okay? So, and we'll go through those, don't worry. But if you ever have a reaction with more elements than just hydrogen and oxygen, it's very important to just leave hydrogen and oxygen until the end if possible. So leave the okay. Now step 5 is to just check everything. And that's basically a step-by-step guide on how to balance reaction equations. And remember, you can only change the coefficients and never the subscripts. Okay, let's try another example. CH4 plus oxygen gas into carbon dioxide and water. This is what's known as the combustion of methane. Now, a combustion reaction is a special type of reaction which we will cover in a separate video. So, but for right now, let's just focus on the context of balancing the reaction equation. So, for the combustion of methane, let's break this down. And it's always very good to counting the carbons first. Okay? So on the left, we have one carbon, and on the right, we have also one carbon. Okay? So one carbon, one carbon. We have one C on each side. Okay? So the carbon is already balanced. Now, let's go to the hydrogens. On the left, methane has 4 hydrogen atoms. And on the right, water has 2 hydrogen atoms. So to make 4 hydrogens on the right side, we need to put a coefficient of 2 in front of the H2O. Now we have CH4 plus O2 into carbon dioxide and 2 water molecules. Now hydrogen is balanced. Finally, let's count the oxygens. So now that we have a coefficient of 2 on the water molecule, that now means we have 2 oxygen atoms. But that's just not all it for the right side. We also have 2 oxygen atoms on the carbon dioxide. So all in total, there are 4 oxygen atoms. Now on the left side, we only have oxygen gas, and it's just going to have 2 oxygen atoms, okay? So the product side has 4 oxygen atoms in total, and on the left, there's only 2 of them. So to get 4 oxygen atoms, we need to put a coefficient of 2 in front of the oxygen gas. So we have methane plus 2 molecules of oxygen gas into carbon dioxide and 2 molecules of H2O. Now let's check everything. All right, this is going to be the final check. We're going to go down here. So we have 1 C, 4 H's, and 4 O. We have 1 C, 4 H's, and 4 O's. Everything is balanced. So this equation is now balanced. So there's one common mistake, and that is actually changing the subscripts, which is something we were telling you about that you're not supposed to do, is you can change the coefficients, but you cannot change the subscripts. So I'm going to use the reaction that we just did. And if you guys remember, if we needed to get more oxygens, we always have to put a coefficient in front of the oxygen gas or the water, depending on the context of the reaction. What you cannot do is you cannot change H2O into H2O2. You cannot do that. That is changing the subscript, and you're getting a completely different reaction because you have a different substance. So that is the very common mistake people do, is that if you need oxygens, you can, I can probably just change the subscript. Don't do that. You're always doing coefficients, okay? Because once we do that, that's changing water into hydrogen peroxide, which is a totally different compound. So we always need to do a coefficient in front of the compound. All right, I have another practice question. I want you to pause the video and try this one for yourself. Now, hopefully you have that solved. So we're just going to walk through it together. Let's solve it, okay? So on the left, we have aluminum and oxygen gas. Okay. And on the right, we have Al₂ and O₃, which has 2 aluminum atoms and 3 oxygen atoms. So let's split this up and let's just kind of list the things that we have right now, okay? So we have 1Al, we have 2 O's, and on this side we have 2 Al's and 3 O's. Not OS, my bad. Mistake right there. Okay. Oxygen is very tricky here because we have O2 on the left and O3 inside Al₂O₃ on the right. So there's a method of doing this, and it's something called the lowest common multiple. Now, the lowest common multiple of 2 and 3 is 6, okay? So we want 6 oxygen atoms on both sides. So to get 6 oxygen atoms on the left, we need to put a 3 in front of the oxygen gas. Now the right side, to get 6 oxygen atoms on the right, we need then to put a 2 in front of the Al₂ and O₃. Now our oxygens are actually balanced. Now the right side has 4. So we're going to change this because this is now 4. Change this because this is now 6. And then also change this because this is now 6. Now this is a very simple fix. Guess what? We need to put a 4 in front of the Al, and we are all balanced. It's always good to do a final check. So we have 4 aluminums, 6 oxygens on the reactant side. We have 4 aluminums and 6 oxygens on the product side. This equation is now balanced. So the key to balancing equations is simple. You need to count the atoms. You need to adjust the coefficients. Never the subscripts. Start with the elements that appear in only one compound on each side and save hydrogen and oxygen for later when it's possible. If this helped, make sure to practice a few more examples because balancing equations becomes much easier with repetition. Thanks for watching, and I will see you in the next general chemistry lesson.